Hi everyone, I am Harshvardhan, an artificial intelligence engineer, and you are watching Another Web YouTube channel. And in this lecture, we will continue with the previous topic where we have discussed about the concept of multitasking in Python. So in this lecture, we will learn how to implement multithreading and multiprocessing in Python using concurrent.futures module. So let's get started. And if you have not yet subscribed, hit the subscribe button and also hit the notification bell icon so you don't miss any of our upcoming videos. So at first we will implement multi-threading using threading module, and then we will implement the same using concurrent.futures module. So I will just import threading and I will import time, and we will define a function, say func1, take an argument, say x. For I in range of x, we will say print I with end of, it should be a string \t. So what this particular statement means, it means that in general, if we don't provide this end argument or parameter, the output will be something like this: 1, 2, 3, and so on, right? So after providing this end statement, how things will go? It will go like this: 1, then a tab, then 2, then a tab, then 3. So output will be like this. Now I will define another function, say func2, which will be identical to the function 1, but the name will be func2. Let me write the code and then I will explain how things are working. And right here I will say print and executing from main thread. Now we will say t1 is equals to threading dot thread, and we will say target is func1 and argument is 10. We have t2 and we will say threading dot thread, target is func2 and argument is again 10, right? And now we will say print executed, but at first we need to start t1 and t2. So I will say t1 dot start and t2 dot start. Great. So now I will just run the file, and here you can see that we got an output of executing from the main thread, and then all the output from these two functions, and at the end we are getting the executed. So now you will ask, where is multi-threading? That means everything has occurred sequentially. At first this particular statement was executed and then this particular statement was executed, right? So to demonstrate this, what I will do, I will say time dot sleep, and I will say provide a sleep time of 2 seconds. Right, and again let's clear the command window and rerun the file. So here you can see that at first we got an output of executing from the main thread, then we got this particular output 0 to 9, then executed, and then we got this particular output. So the first row represents a function from t1, that means the output from t1, and this from t2, sorry, function 2. So to demonstrate it, I will just provide here function 1, and here is function 2, right? So it's better to write f1 and f2, I think, so it will be more readable, right? Right, now I will clear the command window and rerun the cell or file. So here you can see that at first we got an output from here, executing from main thread, and then F1, then executed, and then after 2 seconds we got the output of function 2. So let's understand how this particular file is executed. So here, see, at first we have imported the threading module and a time module. So after that, we have defined two different functions. One is function 1 and another is function 2. In function 1, we have provided an argument x, and for that particular x, we are writing a for loop that will print f1, right? And in function 2, we have again provided a parameter x, and this function will also print f2 for the number of time we will provide x, right? But in function 2, there is a one important code called time.sleep2. What this particular statement will do, this statement will sleep. That means this statement will pause the execution of this function for 2 seconds. So the code will stop executing for 2 seconds at this particular step. After that, we have a statement called print, and in this statement we are printing executing from the main thread. Here at T1 and T2, so these T1 and T2 are thread 1 and thread 2, and we are creating two different threads. One thread for function 1 and one thread for function 2. And we will provide args equals to 10. So that means this particular x is provided through this args. So here you can see that I am providing a tuple of 10 to this function 1. Again, for args of function 2, I am providing 10. And right here we are starting these two threads, thread T1 and T2. Here we have just created two threads, but we haven't started them. So here we are just starting them. And then at the end we are saying just print executed. So how the flow is going? At first we have the main thread. So I will just say M for main thread. So from here, let me do this here. M is for main thread. And say till here we are having the main thread. We are having the main thread. And till here we are having the main thread. So I will just say till line number 19. We are having the main thread. So I will just remove this. Oops. Okay, let me do this again. From line number 20, we are creating two different threads. So what will happen? We will have a thread T, that is main thread, another thread called T1 thread, and this will execute in parallel, and we have another thread called T2. Right. So T1 and T2 are the child of this particular main thread. So at first what will happen? We have printed this statement because we have till here we have no other threads, no child threads. So we have printed this particular statement. Then we have two different threads. Thread T1 will execute this particular function func1, and this thread T2 will execute this particular function called T2. And this print function, that means this print statement, will be executed on the main thread. That's why you will see in the output. So let me take you to the Visual Studio Code. So right here, if you see, you will find that at first you have printed this statement executing from the main thread. Why? It's printed from the main thread. Then this particular function f1 is printed because almost the time required to execute this and this particular statement is same. That's why you have printed this statement. If I say time dot sleep for, let's say, 1 second, or here we have 2 seconds, find that executed will be printed before this f1 statement, that means this f1 code. So let me execute this one. So here you can see that at first you got an output of executing from main thread, this particular statement. Then you can see we got an output of executed. Why? Because now we are skipping this. Actually we are not skipping. What we are doing, that this T1 is taking some time. That's why this particular function is working on thread T2, and the function f2 is also taking time. That's why it's executing in thread t2. But this particular statement, print executed, is executing on the main thread. That's why after this particular statement, the code to execute on main thread is this one. That's why you got an output of executed at the beginning rather than at the end. I hope the point is clear, right? Now you may be thinking that how to prevent that. That means how we can perform that this print executed statement will be printed at the end. So for this, you just need to say t1.join and I should say t2.join. So what this will do, I will again come here and I'll show you. Let me remove all this. Till here you have executed, that means till line number 19 you have executed on the main thread. And one second, and from the line number 20 you are creating two different threads. So one is thread T1 and one is thread T2. So this is T1 and this is T2. So after writing here T1.join, how things will work? At this statement, that means at T1.join, the main thread will stop executing and it will wait till T1 will merge to this particular thread. That means it will wait till T1 thread will merge with the main thread, and when we write T2.join, it means that the main thread will wait till T2 joins the main thread. Once the T1 and T2 will join the main thread, then execute the code. That means at the end, print executed statement will be executed. So let me show you the same. So I will just clear the screen and I will rerun the file. So here you can see that we are getting executing from the main thread. Then T1 is executed. That's why we have F1, F1, F1. Then F2, F2, F2. Why? Because at first T1 is merged to the main function. That means main thread. Then T2 is merged from the main thread. And at the end, we got an output of executed. So I hope how the multi-threading is being implemented in Python is clear to you. If not, just let me know. Now we will implement the same using concurrent.futures module. So what I will do, I will just create a new file. So right here, I will create a new file, say multi-threading concurrent.futures. It's better to write here -py. So to implement this, I'll just take you right here and I will just copy this. Being a lazy person, I'll just do that. So here at first you need to import concurrent.futures, import thread pool executed, and you need to import time so that I can demonstrate you. And again, being a super lazy person, I will just copy T1 and T2 function, paste it here. So just similar to this function 1 and function 2, I have T1 and T2. So there are some special things I have included, like you can see that here I am doing start time.time and here at the end time.time. So why I have did that? So that I can understand how much time required to execute this particular function T1. Again, the identical function with a different name, T1 and T2. So now we need to implement multi-threading. Till here we haven't executed anything. Now we are going to implement multi-threading using the module concurrent.futures. Now again, just let me copy and paste these two statements. So here we are going to implement the multi-threading in Python using the concurrent.futures module. So it's recommended to use with thread pool executed. That means the context manager. You should use this particular context manager, that means the with statement thing, to implement the threading. So what we are doing, we are creating a context manager with thread pool executor, and we are providing a parameter called max worker equals to 2. What is this? I'll let you know. And here we are creating two different threads. One is future1 and another is future2. What is this future1 and future2? So this executor.submit will return something, and that something is actually a type of future. So here we are doing executor.submit t11 and executor.submit t2234. What does this mean? I'll just let you know in some second, and at the end I will just say print these two statements. Right. So see here. At first, we have imported concurrent.futures, import thread pool executor. We have defined two functions, and the important point is that here you are taking a parameter. Since you know how to implement the multi-threading, so I will be skipping the part how things are implemented using threading in Python. So here I will tell you how to implement the same using the concurrent.futures module. So here you can see at first we have provided a parameter x, and at the end we are providing a return statement. Similarly, here we are providing different parameters. Doesn't matter we are using these parameters anywhere in the code or not. I just want to tell you how to use how to provide arguments using multi-threading. So here we are giving three different parameters x, y, z, and again we are returning something that is in -start, that means time required to execute the particular function t2. Now here we have a thread pool executor max worker is 2. So what does this mean? Let me take a screenshot of this. Now, one second, what I have did? Yes. So this max worker is 2. What does it mean? It means that here you have a pool of threads. So this is a pool of threads, and in this pool you have two different threads. Now you will ask why we have provided 2, why we haven't provided 4, 6, 10. Yes, you can provide. If you have 10 different things to execute on 10 different threads. Here we just need to execute only two different functions. One is t1 and t2. That's why I have provided 2 as a max worker. So we have a pool, and in that pool we have two different threads, and these two threads will be used to execute function t1 and function t2. So this, let's say this is t1 and this is t2. So on these two threads is used to implement that. And how we will implement that? We have created an executor, and we will use a submit method on executor to submit function t1 and the parameter required or the argument required to that particular function. Again, here you can see that we have provided t2 and xyz. We have three different arguments to provide. That's why we have provided 2, 3, 4. So at first you just need to provide the function name and then the number of all the arguments that are required to provide. Right. Now at the end, here you can see that it says future1.result. So this result method will return the value returned by the particular function. That means, as I told you, this so here let me just clear this all. So this particular statement, executor.submit executing function t1 with a parameter 1 will return a future type object, and this future type object will have a method called result method, and using this result method you can grab whatever is being returned by that particular function. Here we have only t2, that's why I am pointing that. So again in t1 we will have a return end minus start. So the value, that means the time required to execute that particular function will be returned, and that will be returned using this particular statement, future1.result. So let me execute that particular file and you will understand everything. So one second, let me clear it and again run the file. Just zoom it. Right. So let me tell you how things are working. So here you can see that at first we have printed t2 started, and then the processing value from t2, then t1 started, then all the outputs that we are processing in the function. But the main aim to show this result is that we have successfully provided the argument, these all argument, and at the end you can see the returned value. That means these returned value from the function is printed using future1.result. So here you can see that the time required to execute T1 is 0.0009, whereas time required to execute T2 is 0.001. As I told you, in multi-threading in Python, things are working concurrently, not parallelly. That's why you can see such kind of error, right? So here I have just made things correct, so I will just execute the same once again. So here you can see that at first T1 started, processing value T1, T2 started, everything working concurrently, T1, T2, T1, T2, right? And then T1, T2 done. At the end, we got a return value from T1 and T2. So that's how you can execute the multi-threaded program in Python. But you may ask, Harshvardhan, where we have provided the join statement. That is the work, that means that's the magic in this particular context manager. Main thread will pause till this particular context manager is executing. That means at this statement, the main thread will stop. It won't execute these two particular statements. Whereas, let's say in this particular, if you have 10 different functions, you need to do 10 times of start and 10 times of join. But here you just need to execute them in the context manager, and it will pause the main thread till this particular context manager is not completed its task. And at the end, it will start the work of main thread, right? So I'll just show you one important thing. So here I will just copy the main function and I will paste it right above the context manager, and I will say main. Save that, execute this. So here you can see that we got an output of printing line 1, line 2, line 3, because now you have two different, I should say, alright, here we have only two as a max worker, because we are not executing main in the thread. Main will be executed in the main thread, right? So we have only two threads for future 1 and future 2. So main will be, since main is executed on the main thread, that's why it's printed at the first. And then we have from output from T1 and T2, and at the end we got this two return value. Now you have written the program for multi-threading. To convert this particular program to multi-processing, what you need to do, you just import this particular statement. That means from concurrent.futures, you need to import process pool executor, and right here, instead of writing thread pool executor, here you will say process. Run the file and everything will be executed in the main. Oh yes, you got an error. Why? Because I am working in Windows machine. So I just need to provide a statement, and this statement is this one. So what is the use of this particular statement? It will check whether this particular code is that means this particular file is directly executed or it is being imported and then executed. So here we will say if name is main, and inside that we need to execute the context manager and the output. So the aim of so to prevent this particular error, you need to do this, and at least in the Windows machine. I don't know about whether you are getting this error in Linux or Mac. If you are getting, then just try this hack, whether it works or not, and let me know. Otherwise, if you don't get, just execute it. But for Windows user, you need to use this particular statement. I will just clear the command window and run this. So here you can see that we got printing from main line 1, line 2, line 3, and then T1, T2. And here you can see that we got the return value. So to implement threading and processing, that means multi-threading and multi-processing using concurrent.futures module is really easy. And I would like to tell you a fun fact. After learning this multi-threading and multi-processing, it really made things easy. Let's say when you are working with the text data and you have to process a lot of rows, then you just have to, if you are not using multi-threading or multi-processing, you just have to wait and say, Mr. Device, just do things fast, yaar, right? But when you are executing multi-processing or multi-threading, then you are really going to save a lot of time. So I recommend you, if required, you just use multi-threading and multi-processing. So if there is any doubt, just let me know. Thank you. See you in the next one.